For example, Sarah goes to her local pizza parlor and orders a pizza. She can choose either large or medium, has a choice of 7 different toppings, and can have 3 different choices of crust. How many different pizzas could Sarah order? This is a counting principle, which means I can choose from 2 sizes, 7 different toppings, and 3 different choices of crust. Two times 7 times 3. Now, I want you to think about what if you could have 2 toppings. And if you could have 2 toppings, are you allowed to have the same 2 toppings, or would they have to be different? I'm going to show you. So I could have 2 sizes. If I could have 2 of the same toppings, it'd be 7 times 7 times 3. If it was being counted as using the same topping again. But if it was a different topping, I could choose from 2 sizes. My first topping I could pick from all 7, but once I've used a topping, if they don't allow me to use the same one again, I only have 6 to choose from now. And then the crusts I can pick from 3. 2 times 7 times 6 times 3. Example 3, Derek must choose a 4-digit PIN number. Each digit can be chosen from 0 to 9. How many different possible PIN numbers can Derek choose? You have to be really careful on this one because sometimes we think 0 to 9 is 9 numbers, but it's actually 10 because you can pick 0, 1, 2, 3, 5, 6, 7, 8, or 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers total to pick from. So 4-digit PIN, I'm going to make the blanks kind of like on your phone how it does the dots for your PIN, and we're going to fill them in. So does it specify if we can? Derek must choose a 4-digit PIN number. Each digit can be chosen from this. So they can repeat. You can pick any number. So my first number I'm going to pick from this list. I have 10 options. My second number, I'm going to look at my list. I have 10 options again because I can use repeat numbers. Look at my list. I have 10 options. I look at my list again. I have 10 options. There are all of my pins that I could choose from. So when you think about it, the reason that a lot of passwords require more digits, it's because it makes it less likely. It gives more options of pins. Example 4. Jenny has 9 different skirts. They're listing out properties. So this is accounting again. 9 different skirts, 7 different tops, 10 different pairs of shoes, 2 necklaces, 5 bracelets. In how many ways can Jenny dress up? 9 skirts, 7 different tops, 10 different pairs of shoes, 2 necklaces. We're going to say she can only wear one at a time, and 5 bracelets. Whoops. $6,300 ways, or different ways Jenny can dress up. Example 5. How many 2-digit numbers can you make using the digits 1, 2, 3, and 4 without repeating the digit? Okay, so I can't repeat. So I can pick from 1, 2, 3, 4 numbers. So let's see, 2-digit number. I have 2 spots I can fill in for a 2-digit number. I can pick from 4 numbers first. Without repeating means that I can't pick from these 4 again. If I use a number, I can't use it again, which means now I can only pick from 3 numbers, which means there are 12. And I'm going to check it because I want to make sure. 12, 13, 14. Those are all 2-digit numbers with 1 in front. I can make a 21, a 23, and a 24. Make a 31, 32, 34, 41, 42, 43. And then without repeating, how many 2-digit numbers can you make using the digits without repeating? 11. Those would be repeating numbers because they would have 1 repeated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If it could repeat, you would have 13, 14, 15, 16 of them, if they could repeat. Example 6, in how many ways can you arrange 5 different books on a shelf? So I'm arranging 5 books on a shelf. There's room for all of them. When I place the first book, I can pick from 5. My next space, I can only pick from 4 books because I've already placed 1. And I can pick from 3 books, 2 books. The last one goes at the end. 5 times 4 times 3 times 2. I can organize the books in 120 different ways. A shelf can hold 7 trophies. I'm going to make spots for them. How many ways can the trophies be arranged if there are 10 trophies available? So the first spot, I can pick from 10 trophies. I've used 1, so now I only have 9. 8 trophies to choose from, 7, 6, 5, 4. The rest do not have spots, so they are left off of the trophy case. That is how many ways I can arrange my trophy case. Example 8. Your state issues license plates consisting of letters and numbers. There are 26 letters, and the letter may be repeated. Ooh, good. So we can repeat. There are 10 digits, and the digits may be repeated. how many possible license plates can be issued with 2 letters and 3 numbers? So if they can repeat, I have 26 letters to pick from for the first, and I can pick from 26 again, because they can repeat. Then the numbers, I have 10 to pick from, 10 to pick from, 10 to pick from. Multiply it all together. Those are how many license plates I can create. If it said do not repeat, or no repeating, then that 26 would be fine, but the next one, if it could not repeat a letter, it would go down to 25 because I've used one of the letters already. Same thing with the numbers. If I had picked 10, if I'd used one of the numbers and I couldn't repeat it, I can only pick from 9 numbers now. And then I could only pick from 8 numbers if it's not allowed to repeat. So depending on the state size, that's why we are allowed to repeat. And if you've noticed, some states have different amounts of values. So if you have a ton of people, you're going to have more letters. So let's say it's a big state. You would do 1, 2, 3 letters that can repeat. Because it can accommodate more people. So just by adding that extra letter on, our value minus 6, it just added on. Oh, that was weird. Minus. That's how many extra license plates you have just by adding on that 26, that one extra letter to your license plate. So now you know how to do factorials and counting principles.